they have to have is they just have to have a route to our routers, a default route to the router, and then the router has a route to the other networks. So I'm just going to see if I can ping host B. I call that host.office B. And I can't for some reason. Okay, let's see if I can ping the router. Okay, I can talk to my router, and I do have the route. So let's get back on the router and see why this is not working. Okay, I'm on router A. Let's see if we've got the routes on router A. Okay, network B is here, and the gateway is through the other end of the link. So that should work. Let me see if I can ping it from here. Okay, so the router can get to the host on Office B. So we need to figure out why the host in Office A can't get to the host in Office B. Okay, one thing that you need to do that I'm not sure if I did it here is to enable IP forwarding in Linux. You have to actually turn it on. So it's in proc sys net IPv4. It's like called IP forwarding, I think. Okay, there's our problem. You have to make this a 1 or it will never route packets. So all your routers need to have routing turned on. I need to echo, not cat. Okay. And that should do it. Normally you do that somewhere in your startup script. I just neglected to do that. So let's get back here. We're on host A and we want to talk to host B. Okay, now it's working. And let's look at the route that it's taking. Oops, I want to do trace route. Trace route to the host in Office B. Okay, so we go to our router on Office A. From the router, we go to the opposite end of the link, the VPN link, which happens to be the router in Office B. And from there, we reach the host in Office B. And all we need on our host is just the route. Is just the route to our router, which is running OpenVPN. So it's nice that that worked. We could add another office pretty easily just by running an OpenVPN client here that connects to Office A, and then we can run another OpenVPN client that connects to Office B, and just as long as all the routes are there, everything will work fine. I'm not going to do that. Trust me, it works, because basically it's the exact same thing. We're just adding other routes. If you wanted to do this in a more fault-tolerant way, we're doing all static routes, but what happens if, this route goes away and Office C wants to talk to Office B? Well, if this goes away with static routing, it's going to have no way to get there. But you could run some kind of dynamic routing protocol like RIP or Open Source Path First, which I know nothing about, that would actually dynamically create the routes. And then our OpenVPN, we wouldn't have those routing directives at all in OpenVPN. We'd leave it entirely up to our our dynamic routing protocol. What else we got? Okay. If you're going to be using OpenVPN like I do, which is a way to get to my home network and not have to use, the Starbucks gateways, or the school gateways or whatever, you might want to connect to your VPN in other ways besides just UDP over the internet. And you might want to use Tor. Tor is an anonymizing network that's pretty easy to use. It anonymizes IP connections. Of course, it's kind of slow because you're getting routed through all these other machines. And you might want to use this when you don't want your first hop to see who you're connecting to. You're not going to really use that a whole lot. DNS tunneling, I actually use a lot. Remember that first slide where we had an entire packet inside the payload of another packet? Well, there's no reason you couldn't put a packet inside the payload of a reply from a DNS server. So if you can control your own DNS domain, you can send packets by requesting, like a randomly named DNS name inside your domain. And so your packet is inside the name, and then the packet on the way back can be inside the return to the query. Of course, you have to control your own domain in order for that to work. And I do that sometimes. Let me show you how this works. I am just going to bring down my connection that I have right now, and I'm going to connect to my VPN through DNS tunneling. And well, why would you want to do that? Well, when you go to Starbucks or you go to a hotel, usually you're behind a captive portal. And the way that a captive portal works is that it intercepts, it pretty much firewalls you off from everything except for DNS and except for web. And it transparently intercepts all your web traffic to direct you to a web page where you log in and put in your credit card or click I accept or whatever. Well, they allow DNS traffic to get out because they assume you might cache the results, and they don't want it to mess up your web page viewing once you log in. Well, we can use that to start a link through our DNS tunneling. And sorry, I'm just closing out all these million shells that I have so I don't get confused with all these shells. Okay. This one is unresponsive, so let me just start a new one. I am going to open up a DNS tunnel. And the best DNS tunneling package out there right now is called Iodine. And you need a password. And so obviously I'm going to have to change the password after this. And I think -f keeps it in the foreground. And my tunneling domain is t.frop.net. Iodine-p t.frop.net. Nope. Well, okay, it wants to be root. They do, and I'm just so used to typing SU. So we're going to run Iodine. And our password is KSDF. And we want it in the foreground. and t.frop.net is our tunnel. Of course, I'm running this on my server too. So we're going to connect. And hopefully we'll still be able to get through, because remember I changed my routing tables. Let me just reconnect to the wireless.
You're already connected. Oh.
Yeah, but remember I deleted my default route, so it may not be able to get back through there. Okay, so let's try this again. Okay. So I've run Iodine on my client, and it's connected to my server. And Iodine gives me a tunnel device, except for it calls it DNSO. So let's just look at DNSO. I should have just logged in as root, because I keep on. Okay, so I've got a DNSO device, and this is my Iodine tunnel. I'm going to use this tunnel to connect OpenVPN, connect to OpenVPN on my other machine. I could also do IP routing through here, but I just already had my OpenVPN set up, so I just do that.
Is it Iodine that creates a DNS?
Iodine creates this DNS tunnel. And I actually kind of do it a silly way. I run OpenVPN to create a tap device over the tunnel device. So it's kind of convoluted, but that's how I do it. So I'm just going to run it to show that it can be done. So I've got my TAP3 device that's connected over the DNS tunnel. So now I can just do